Now we will talk a little bit more about the MCP core component. So when you think about the MCP system, you would have these two main components. One is the MCP client. Clients are the ones who are going to make the request. And then you have the server, which are actually going to be processing the request, very similar to traditional client server definition. Now, the server typically includes a host, app, and an LLM component as well. And we'll dig a little bit deeper on the server side. Now, if you look at the host, these can be any kind of desktop application or custom built agent, which is having an LLM and which is also serving as an MCP client. Now, next I'm going to talk about is the protocol layer. So the protocol handles the structure of the message. Here is an example of a tool called getWeather. The request is formatted as JSON RPC 2.0. It includes an ID, method, and parameter. The standard format ensures interoperability. Now, the transport layer handles both messages that are physically transmitted. It's communication channel between the client and the server, and MCP supports multiple transport layer. So it has the standard IO and streamable HTTP and SSE, which is being deprecated. So we'll focus more on the standard IO and the streamable HTTP. Now, if you look at the standard IO, these are the ones which are ideal for local integration. And for simple implementation, for example, if you use some kind of a CLI tool or a shell script wherein you're going to connect with an MCP server, and it is using communication through standard input and standard output stream. And the one which is more useful for production grade implementation, wherein you need stateful and stateless sessions, is the streamable HTTP. It is an HTTP post for client to server communication. Now, if you were to break down even further the concept of MCP client and MCP servers and what are the different pieces that comes along with it, are these three different constructs. So first one we have is the tools. So tools are the functions that the LLM can call to perform specific actions. For example, a weather API, or looking up the database, or updating the customer profile, or looking up the order, creating orders. Resources are the data sources that LLM can access, similar to get endpoint in a REST API. And resources provide data without performing significant computation. Prompts, as the name suggests, are the predefined templates. So these are like prompt templates to use tools or resources in the most optimal way, and it is selected before running inference. Now, having these three different concepts of tools, resources, and prompts, these are the ones which the MCP server exposes. And the clients, actually, when they make a call to the server, they invoke or use those resources. So here is a little bit more deeper explanation of that, right? So you have your MCP server. The way you can call the MCP server is using the standard IO or HTTP streaming. And your host will actually invoke the question using this transport layer. And the MCP server will then use all of these tools, resources, and prompt, and then respond back to the host, whoever is asking question, and fulfill that request. Now, looking at the complete picture, you can see here, we have the user interacting with the MCP client, the client which connects to an MCP server, the server interfaces with the data sources, API, and LLMs. Now, this creates an end-to-end solution. Now, each component has specific responsibility. The requester handles the authentication and request generation. Agentic LLM application manages the workflows and tool calling. and then the context server interfaces with the databases and the API. Now let's walk through a typical request response flow. So the user will submit a query. The host processes the query. MCP client requests available tools from the server. The server returns the tool definition. The client selects the appropriate tool and parameter. The server will process the request and return a response. And the client will integrate this response into the user experience. Now, this is a very standardized flow, but it is simplified flow as well because it simplifies the development and ensures consistency. Now, let's take a simple example of how we would build an MCP server. So when Anthropic announced the Model Context Protocol, they also put in this library, which is called as the fast MCP. And you can see this is simple Python code wherein I'm importing the library. I'm defining the MCP server. Here I'm defining the MCP server name weather. And then I am defining the tool, which is get forecast, as part of the server. And once I've defined the tool, I can essentially start a server on my local machine. Now, if I'm a client who wants to call that server, again, what we would do is we would import the client session from the MCP library. You would add in the details about the initialization. You would do the tool discovery. And note that I'm using the standard IO transport, which is good for local development, as I said, and it uses standard input and standard output. And after initialization and tool discovery, you can do the LLM integration, and then you would invoke the tool and get the response. For example, tell me the weather in San Francisco. And the LLM will convert that query from a user to call get weather and pass in the location as San Francisco.